Internet infrastructure. The way networks in the internet fit together is referred to as the internet infrastructure. And there are different kinds of tiers in the overall infrastructure of the internet. Tier 1 networks, some examples of which are AT&T, CenturyLink, Verizon, and NTT Communications in the United States, represent the top of the internet hierarchy and form the internet backbone, a system of high-capacity routers and fiber optic communication links, providing the main routes for data traveling across the internet. Networks that form the internet backbone are maintained by internet service providers. So here's some example of tier 1, tier 2, and tier 3. So at tier 1 level, we have the big guys actually providing the connections to the internet, or the backbone, essentially. Then there are sort of smaller internet service providers like Comcast that connect to them. And they're also what is called tier 3, which are also, they can be wide area networks. So these are WAN, wide area networks, where business networks or home networks connect to. So there's this kind of different levels, which may be kind of invisible to us, but essentially establish the overall internet infrastructure. Network packet. The internet uses packet switching technology to communicate data. A packet is a standardized unit of data that is sent across a computer network. Now, notice that a packet is not a bit. Each packet contains a standard set of several bits, usually 32 bits, but it can be higher as well. So this is the standard 32 bits. So think about how many different values that is. And the data packet, which is this kind of standardized set of bits, has a lot of information. It can have a lot of sequence of numbers there. And it has control information, that is information about the source, the destination, and the sequence of where the packet is going. And the data itself, or actually part of the data itself, also known as the payload. To send data over the internet, a device breaks the data into packets and sends the packets in sequence. Not just a device, but the entire program, all those layers of the protocols, the software programs, and the hardware itself. So some example here, so suppose you have an image. You have an image on your computer, you want to send that image, that photo to somebody else. Once you, let's say you want to send it over email. Well, what happens is your email program, along with other layers of the internet communication, are actually going to break down your image and your entire email into little packets. And each of these packets is going to have information about the computer that it's coming from, where it's going to, the sequence of that packet. So the first one is going to be called 1, the second one is going to be 2, and so on. And a little bit or part of the image or part of the email that is being sent. And then it travels through the internet, and then eventually arrives at the destination and is reassembled in the correct order because it has order information and so on. Here's kind of an example. You have a host computer, breaks down the information, the data, into several parts. The piece of data may actually travel through various different kind of computer networks, various different internet service providers, to then be arrived at the destination. And of course, the same happens when you make a request to data and when you send the data as well. This is packet switching. Here's another image on internet protocol layers. We don't need to go deep into this. This is kind of just some highlighting the different layers of the different processes of the data flow So we have talking about the physical layer. Now this is also an abstraction, so don't take this too literal. Physical layer. There's a transport layer that creates the standards for how the data needs to be broken down, and there's the application level layer here, which also configures the information for the transport layer and so on, and for the physical layer and so on later. Transmission control protocol. So the transmission control protocol is one of the foundational protocols of the internet. This is why we call this the internet the TCP/IP. You may have seen this term before. TCP/IP, transmission control protocol, and internet protocol, the main protocols for data to be sent over the internet. TCP is responsible for dividing files into chunks, adding headers containing information for reassembling packets in their original order, and verifying that the data was not corrupted while in transit. Process called known as error checking. The IP protocol determines the structure and information of the packet to be sent over the internet, the payload itself, and where the data is going to. Internet protocol. One of the main components of the internet protocol is the IP address, and that is the unique number of each device connected to the network that can either send or receive information. And these include things like printers or routers themselves as well. They have their own IP address because they are nodes in the network. There are two forms now, essentially, of internet protocol addresses, and that's the version 4 and the version 6. So the version 4 is the original one, and it has, once again, 32-bit address, and it looks something like this, and you may have seen it. 68.56.246.225. This is like the telephone number that identifies a unique device. And IPv6, Internet Protocol version 6 is newer. It uses 128 bits for each address, produces billions and billions of unique internet addresses, and 128 bits allows for a lot of unique addresses. And now just to clarify, actually, this is just the IP address itself. So this is not the full extent of the data packet. And here is some header information on the data packet, just to see all kinds of information that can actually be included in the data packet. So there's information about the destination IP address, the source IP address, things for checking to see if there's an error or the correct sequence of the data packets, the total length of the packets, protocol that it's using. So it's fairly complex, and there's a lot of information that is in each data packet for the data to be able to be sent to its correct destination and also received and reassembled correctly. Internet addresses. Each computer or digital device needs its own unique IP address. IP addresses can be assigned by a network administrator, but more commonly nowadays, perhaps, I'm not sure if more commonly, but largely common, they're also automatically assigned by a dynamic host configuration protocol. And every device has one, and you can check out what's your IP address you can check it on your own computer, you can type it on the search engine, they can tell you what's your IP address. The IP address may be a kind of difficult number or a difficult name of a particular device to remember. So a domain name system was established to translate the numbers, translate the number of a particular device or a particular site, a particular server that has a web page or a web application or any kind of application, to a kind of more memorizable kind of name. And this is what the domain name system does. The domain name system is the mechanism for tracking domain names and their corresponding IP addresses, and that is what ICANN manages. A domain name ends with an extension that indicates its top-level domain, such as edu or org. So the top level is actually the end here of a web address, such as edu or .org. Domain name servers are scattered around the world and maintain lists of all domain names and their corresponding IP addresses. I think I have another diagram here to kind of illustrate a little bit how this works. So, so we have a computer here. This is your, let's say, personal computer or office computer. You want to go to a website and you type on your browser www.nike.com on the browser itself. Now, your browser doesn't know the IP address of Nike.com. The IP address and the domain name of all websites in the world are not stored on your computer. Maybe your computer is brand new. It doesn't really have much information in it. So you make a request to Nike.com. So the information goes to, once you do that, the information has to go to a DNS server, domain name system server first, check to see the IP address of Nike.com, sends that information back to your router, and then your router actually connects to the page via the IP address, because it ultimately needs the IP address to go there. And then the image is returned back, or the web page itself is returned back to your computer. And that happens, of course, in a split of a second. Some other components that are important here to know in this context is the DNS registrar. So anyone can purchase a domain name if it is already not in use via a domain name registrar, which are companies that manage the reservation and assignment of domain names. These companies must gain access to the domain name registry, which is a database that actually records the names and of the domain names and who owns what. The domain name system gets very complex very quickly, with several agencies managing several components of these processes. So here, once again, we're just having an introductory overview of the system. Of course, there are issues with the domain name system. One is related to spoofing and hacking. So altering domain name system servers, DNS server records can change the destination of your email or browser connections or download requests. So for example, if somebody can hack a DNS record that changes the IP address of a site, let's say Travelocity. So instead of the original site, they put a fake site there. When your computer connects to Travelocity, it receives back this wrong IP address. And then your computer is actually going to connect to this wrong IP address here, which may not be safe, which may download some things you don't want to download or something like that. So that's called DNS spoofing, and is a particular problem in the internet. There are there are several issues as well we can talk about. Here's just one that's kind of interesting to know, and this has to do with the DNS registrar itself. So that is the ability of somebody to just make up a domain name that sounds official, sounds credible, but may not be. So this is something to be concerned. Research indicates that thousands of new domain names using terms like COVID or Corona are being used for spam, phishing, malware campaigns, and to peddle fake products, right? So if you can just go and buy any domain name, so you buy something called Corona, facts, .com, then perhaps this can give the site a credibility. Maybe this name doesn't give credibility, but something like that. And so that can lead people to think that the site is credible and so on, and try to sell stuff or try to somehow swindle other people. Author of the study that I'm referred to here, that's referred to on the site, indicates that domain registration data is supposed to be available in guaranteed, reliable ways. Unfortunately, we documented widespread failures, both technical and legal, that is, of making domain registration data. So it's kind of hard to know who made up this site here. Once again, it's a very complex system, various organizations, various entities, various processes, and there are some serious issues out there. This is a good introduction for now, and I'll see you next time.